and the functions, right? So there is a small mirror installed in it, right? So that mirror is also concave mirror, right, everyone? Next thing is that concave mirror are used by dentists to see the large images of teeth, right, everyone? Sure, that's great. And concave mirrors are used as reflector in torches, vehicle headlights to get a powerful parallel beam of light. So parallel beam of light is basically produced when the basically source light is placed at the focus or near the focus. Everyone, right? Sure, that's great. Next is large concave mirror are used in the field of solar energy to basically heat up the furnaces. Solar furnaces are there to basically melt the, you can say, steel, iron, and all the things, because you know that to basically melt steel and iron and the very high melting point metals, like you need a very high amount of fuel, right? So to avoid that fuel consumption, the solar furnaces are used in that place, right? So that the renewable source of energy is used instead of non-renewable, right? Actually, that's great. Now, okay, so let's understand the convex mirror, right? So convex mirror is the mirror that is basically the mirror that is used to diverge the rays. So convex mirror diverges the rays. It means that spread out the rays in a very large area, right? Clear? So convex mirror, let's understand the properties of convex mirror. That convex mirror always form virtual and erect images. Convex mirror always form diminished images. It means that whenever the convex mirror forms an image, it would be diminished at any cost, irrespective of the object place, right? Place of object. Clear, everyone? Is this clear to all of you? Please let me know once.
Yes, sir.
Sure,
Yes, sir.
great. Sure, check it. And convex mirror has a positive focal length. Okay, so I've told you that whenever the concave word comes, the lens and mirror, the focal length would be negative. Whenever the convex mirror or lens word comes into the scenario, so the focal length would be positive. Clear? So concave means whether it is lens or mirror, it would be negative. Convex means whether it is lens or mirror, it would be positive side. Clear, everyone? Hello, Gianna. How are
Yes,
you?
sir.
I'm audible. Okay.
Yes, sir.
Sure. Okay. Okay, that's great. All right. Sure. Okay. So now next thing is that convex mirror provides a wide view of vision. So that's why these mirrors are used in the rear view, used as the rear view mirror in the vehicles, right? In the rear side mirror, in the back mirror. So these are used, basically they give a wider view of vision, right? So we can see a wider view so that we can see that whether which object is coming from the back side. Okay. Clear, Harshit, Jana, Maha, Galvin, and Aisha?
Yes, sir.
Yes,
Sure.
sir.
Okay. Now, so in the convex mirror, only two parts or two cases are there for the mirror formation. First would be as simple, all the mirror and lenses, there would be a single common case, that is basically at infinity case. And the object would be formed at the focus, right? So rays are parallel to the principal axis, so they will get diverged. But if I extend in the backward direction so that I can find out whether the rays are originating from a common source or not. So when I've basically extended in the backward direction, there's a point that is basically at which the rays are getting merged. So that point is considered as the focus because the rays are coming parallel. So whenever the rays coming parallel intersects at the point, so that point will be considered as the focus point. Clear, everyone? So object is at infinity, basically image is at focus, nature would be virtual and erect and highly diminished. So whenever the object is placed at infinity, the size of the image would be highly diminished irrespective of the type of mirror or lens. Clear, everyone? Yes or no at least?
Yes.
Chalo, okay, last case and the second case in this, second and last, between infinity and pole. It means that wherever you place the objects between infinity and pole of the convex mirror, the image formed would be virtual, erect, and diminished size. Okay, and the image formed would be between pole and focus of the mirror. So when you basically first raise parallel to the principal axis, it will get diverged. But if I extend in the backward direction, it is intersecting at a point. So that point will be considered as the focus point. Right, everyone? And second ray is basically the following the law of reflection. If I strike the ray basically with some angle I, so it will reflect back with the same angle. So that's why if I extend in the backward direction, reflected ray in the backward direction, so there is a point of intersection between the parallel ray and the ray passing from the pole. So that intersection will be considered as the image formation for the convex lens. Am I clear to all of you? Does anybody have any doubts so far? Please let me know.
Sir, could you please explain it again?
Yes, Harshit, you said something.
Sir, could you please explain it again, this part?
I'm okay. I'm saying that in the second case, the first ray is parallel to the principal axis. Our first ray will be parallel, right? So this is the common thing
Yes.
that we have done so far in all the cases. And the second ray, so basically, if the ray is parallel, it will get diverged. But if I extend in the backward direction, just to see whether it is intersecting at a point at the principal axis or not. So as I've seen that the line is basically intersecting at the point focus, right? So that's why we have basically assumed this point as focus. Is this clear to you?
Yes, sir. Now clear.
Next is if the line basically strikes with some angle at the pole, so it will reflect back with the same angle, Harshit.
Yes,
So
sir.
if I extend in the backward direction, as you can see, this is the reflected ray 1, this is the reflected ray 2. They are not going to meet at all. So that's why we have to extend in the backward direction. So if we extend in the backward direction, you can see there is a point of intersection, and this point of intersection will be called as the image of the object. Clear?
Okay, sir. Clear.
Okay, everyone. So could you please wait for a moment, Bacho? Actually, it's Azan right now. Just wait for a moment.
Yes, sir.
Okay, thank you. Okay, everyone. So please switch on your videos. Let's continue. Thank you so much for waiting. Okay, so now let's understand the applications of convex mirror. So convex mirror are used as the rear view mirror in the vehicles to see the objects at the rear side. As you can see this thing, there is a comparison of the plane mirror as well as the convex mirror. So convex mirror are basically giving you a wide field of view, right? But in the plane mirror, the view is not that much broad, right? So that's why convex mirror are used as the rear view mirror. Is this clear to all of you?
Yes, sir.
Next is the convex mirror are used as the security camera in big shops. So you must have seen that like those who are not able to afford the CCTV cameras and the LCDs to basically monitor all the things. So they basically install the convex mirror, a very big convex mirror at the you can say corner of the shop. Okay, so that they can see, as you can see in the mirror in the image, that the all the points of this shop is covered in the convex mirror. It means that all the activities can be monitored using a single mirror itself. Is this clear?
Yes.
Sure, that's great. As you, like this question we have done in the class, that no matter how far you stand from a mirror, your image appears erect. The mirror may be either plane or convex because it is asking that it is not talking about the size. It is just saying that erect image. So erect image is formed both in plane and convex mirror, because concave mirror is said your image, the object distance does not matter, but in concave object distance matters because there is only a single case in which the image is formed virtual and erect. Is this clear to all of you? Please let me know once. Please let me
Yes,
know
sir.
everyone is okay. That's great. Okay. Sure, that's great. Okay. So now let's do understand the refractive index part. Okay. So we'll do the questions of mirror formula once let's complete the theoretical portion. Okay, now let's understand the refraction of light. So refraction of light is the process of bending of light when it passes from one medium to another medium. Okay, so this happens due to the change in the speed of light. The main reason is that when the light ray changes the medium, the speed of the light ray in that medium changes. So therefore, we observe a bending of light in the so you can say in the medium. Is this clear to all of you? Dalvin, Harshit,
Yes.
Gianna, Maha, and Aisha. Okay.
Yes, sir.
Okay, that's good. I'm not dictating. Basically, we are discussing, so you should you are also a part of this. If you are not clear in any of the portion, you could ask me. Okay. So we are discussing it very in a very general manner, so that because this is a revision class, so our I just wanted to remind all the things, all the concepts that we have done so far in the classes, right? So that's the motive of this revision class. If you have any doubt or any numerical portion that is not clear or any topic that is not clear, you could ask me right there. Okay? Sure. Okay, next is basically refraction of light takes place at the boundary of the two media. Suppose that two medias are basically like this. So this is any A medium, this is B medium. So this point, the boundary of these two medium is this. That is basically separating both the mediums. So this medium will, basically the refraction will happen at this boundary. Is this clear to all of you? Refraction will
Yes,
not
sir.
happen inside the medium or outside the medium. It will happen at the boundary, right? Sure. That's clear. Yeah. Next is the refraction of light happens is due to the change in speed of light when the light goes from one medium to another medium. Greater the difference of speed of light, it means that if the light is traveling with a speed of 3 lakh kilometer per second, right? 3 lakh kilometer per second. Suddenly, when it changes the medium, the speed has dropped to 50,000 kilometer per second. There is a significant, it means that it's a very drastic change. 3 lakh kilometer to direct 50,000. It's a difference of 2 lakh 50,000 kilometer per second. So there is a very huge change. It means that there will be a more bending of light in comparison to the other difference, right? If the light has not decreased, like suppose that 3 lakh kilometer light has decreased to 2 lakh 80 kilometer per second. So there is a difference of 20,000 only. So light will not refract, light will refract, but not that much strength, right? So the difference matters. Is this clear to all of you?
Yes.
Sure. Okay, that's great. Gianna, Harshit, Maha, Galvin, and Aisha. Are there like only Maha, Galvin, and Harshit are responding? What happened to Aisha and Gianna? Are you there in the class, Aisha and Gianna?
Yes, sir.
Yes, sir.
Okay, okay. Maha and Aisha, oh, sorry, Gianna and Aisha, please switch on your videos. Okay. Harshit, what happened to you? You have also switched off the video?
Nothing, sir. Just I'm opening.
Okay, okay. Now let's so basically refraction of light basically happens into basically depends on the medium as well. So we are going to classify the mediums into two broad categories, that is optically rarer medium in which the speed of light is more, and which is another one is optically denser medium in which the speed of light is less. Clear? So optically rarer medium means that in which the speed of light is more is known as optically rarer medium. Optically denser means it means that the speed of light is decreased or less is known as optically denser medium. Clear? Now let's understand how does the ray behave when it goes from rarer to denser or denser to rarer. Clear? So now let's understand. So this is the incident ray. So when the light ray goes from rarer to denser, so the refracted ray will bend towards the normal. It will bend towards the normal. In this case, the incident angle would be greater than the refracted angle. Why? They go. If the light has gone straight, angle would be same due to the vertically opposite angle, right? But in this case, the angle is shifted, the ray is shifted towards the normal. It means that there is basically this angle will get subtract from the original angle, right? So that's why the refracted angle will be less in the rarer to denser case. Is this clear to all of you? Okay, now let's understand the incident ray when it's going from the denser to rarer medium. So when the light ray goes from the from denser to rarer medium, it basically goes away from the normal. In that case, angle of incidence is smaller than the angle of refraction. Why they go? The light should have gone straight. Angle would be same, but this is the extra angle that is basically forming right here. It is produced extra. Yes or no, everyone? So that's why in this case, the angle of refraction will be greater than the angle of incidence. Am I clear to all of you? Is there anyone who is having doubt? Please let me know. Say yes. Is there anyone who is having doubt? Is something not clear to anybody?
No, sir.
Clear to all of you?
Yes, sir.
Sure.
Yes, sir.
Okay. Now let's understand the effects of refraction. So refraction depends on the so basically these are the normal day-to-day life observations. An object placed under the water appears to be raised. When you basically see an object basically sink inside basically in the water, it appears to be raised due to the refraction of light. Okay. Next is a pencil held obliquely and partially immersed in water appears to be bent at the water surface. As you can see this thing, this is the actual example. The image should be formed straight like this. The image should be formed like this, right? But due to the refraction, there is a bending of pencil as well. Is this clear to all of you?
Yes, sir.
Yes, sir.
Sure, that's great. Next is a pool of water appears to be less deep than it actually is. So you must have seen that if you see if you basically observe a swimming pool, you must have seen that the swimming pool looks not that much deep. But in actual, when you go inside the swimming pool, it appears to be a little bit more deep than it is actual. Right? Just a second. Just a second. Sorry, everyone, for the interruption. Yeah. I was saying when when you basically observe a swimming pool or you can say a lake, it does not appears that much deep. But sometimes you must have seen that you must have heard all the news that that the person is basically sinking into the water or the person is found dead in the water due to that due to the depth of the pool or the lake. So basically, the main reason is that due to the diffraction, the depth is not accurate in actual. Okay, so it appears that suppose this is the depth. Suppose this is 15 meter, but due to the refraction, it will appear as 3 meter. You will see that over 3 meter is not that much deep. Just you will go inside into the lake or the swimming pool, but suddenly you found that it is 15 meter deep, and you don't know how to swim, and even you don't know how to basically rescue from that portion. So that's why this happens. Is this clear to all of you? So that's why it's very important to basically avoid these kind of scenario without any proper instructions. Clear, everyone?
Yes.
Sure. Okay. Next is the star appears to twinkle on a clear night. We have done this thing in the atmospheric refraction. So that due to the different varying densities in the atmosphere, the atmospheric refraction happens, and due to that, star appears to twinkle. They actually do not twinkle, but they appears to twinkle. Clear? Sure, that's great. Now let's understand what is lateral displacement. So lateral displacement is basically the shifting of the actual incident ray from its original path, right? And the different distance between the emergent and the incident path is called the lateral displacement. So when the light ray enters into the glass slab, it will refract towards the normal because air and glass. So glass is more denser, it will bend towards the normal, right? And if it will go straight as it is without any refraction because the medium is not changed yet. But at this point of time, at this point, okay, so this is the boundary of the glass slab again. So it will bend away from the normal due to the change in medium. Okay, because it's going from denser to rarer, right, everyone? So if you compare, if you basically extend the incident ray that if you extend the original path of the incident ray, you must observe this thing that the emergent ray and the incident path are parallel to each other. Okay? And the perpendicular distance between these two rays is called lateral displacement. Clear, everyone? Maha, Calvin,
Yes.
Aisha, Gianna, and Harshit. Clear?
Yes, sir.
Yes, sir.
Check. And in this case, angle of incidence is equals to the angle of emergence. This is a very important, you can say, relationship you have to understand and remember. Sometimes in the exams, there might be a question in the MCQ to okay, so they will ask the relationship between the angle of incidence and the angle of emergence. And so I think there was a question in the paper as well, the relationship between the angle of incidence, angle of emergence, and the angle of deviation in the human eye. There was a question, something like that. What was the relationship between angle of incidence, emergence ray, and the angle of deviation? MCQ question. Maha, have you done that question? No. Gianna?
No, the options were wrong. You said
In,
you would, that's the one.
no, that was not. I mean, there was one more question similar to that. Okay, no worries. We will discuss it when we will do the discussion of the test paper. We will do it. No need to worry.
Sir,
Okay?
what's the answer?
But I'll not tell you right now.
Okay.
I will tell you. I will tell you. But first of all, when the test series is over, now we'll discuss that thing. Because some students will take advantage of that. I don't know the there's a record, separate record for that, but I don't know the record for those who have given and those who have not given the test yet, right? So once the test series is over, the discussion part will be started and we'll be doing that thing, right? No need to worry, we'll discuss everything in detail. Every
Are you
question
not the one correcting the papers?
correcting means
Like checking the papers and giving marks?
I'm the one they checking the paper, but I don't know those who have some of the sheets come randomly, right? Every student gives the test in its own time, so that is the reason. So I just check and share it with the management. So I don't know the proper record of that. Okay. So that's great. Okay, so the perpendicular distance between the original path of incident ray and the emergent ray coming out of the glass slab is called the lateral displacement. Clear, everyone? Okay, and one more thing, this is a very important thing. This I'm sure that at least I'm sure the probability is basically around you can say the percentage of coming this question basically in the MCQ part, that the light is basically falling normally to the glass slab. What will be the what will happen when it fall normally, something like that they will give you, that it will refract without any refraction, it will go without any refraction, it will bend towards the normal, it will bend away from the normal, or it will reflect. So there could be some questions. So for that you have to say that if the light is falling on the glass slab normally, it means that there will be no refraction at all, it will go straight. Okay, so right now angle of incidence is 0 in this case. Angle of incidence is 0. Light is making angle with the surface 90 degree, but the angle of incidence is 0 because the angle made by the incident ray and the normal is 0. Right, everyone? So please keep this thing in mind. Like some in the exams, I've seen that thing that some of the students makes these kinds of silly mistake. Okay, so please avoid these kinds of mistakes in the exam, right? Take your time, take a minute or take 1.5 minutes to basically analyze the question, but give mark the right one if you are confident. Okay, so if the light ray falls normally to the surface of a glass slab, then there is no bending of ray of light as it goes straight. Right, everyone? Sure, that's great. So this is the same question. A ray of light traveling in water falls at right angle to the boundary of parallel side glass block. The ray of light, so in this case, it's already said right angles. The ray of light will not refract at all. Right, everyone? Okay, now let's discuss the laws of refraction. Similar to the reflection part, there are two laws of refraction as well. The first law is very similar to the law of reflection, that incident ray, refracted ray, and normal to the point of incidence all lie in the same plane. It means that only two axes are involved, right? Two coordinates to basically two axes, either x, y, y, z, or y, x, z axes are involved, right? And the second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. It means that if you have taken if you have taken a pair of media, suppose air and water, if you change the angle of incidence, angle of refraction will change accordingly to maintain the refractive index. It means that the constant will not change. If you take the ratio, right? So it will be constant for the given pair of media, right? So refraction angle will change accordingly to basically maintain this constant value. Clear, everyone? So that's why in the question, in the exam, there could be a question that write the relationship of refractive index in terms of angle of incidence and angle of refraction. So this is the relationship. Or one more, right? You can write it in this manner. This one is that I'm writing is for the relative refractive index, right? This one is for the absolute, and this one is basically N1 into sine I is equals to N2 into sine R. This one is for relative, because it's easy to solve the relative refractive index in this manner if it's asked, if the angle of incidence and angle of refraction is given. And this one is for you can say the absolute, because here refractive index just would be sine of I by sine of R will be equals to N, right? So, or you can say यहाँ पे मैं लिख देता हूँ N. N means refractive index of that medium with respect to air. And this one is for relative refractive index. When the mediums are not air, when one of the medium is not air, so this relationship could be used. Is this clear to all of you? Please let me know once. Is there anyone who is having doubt in this? Please let me know, everyone. Maha, Galvin, Gianna, Harshit, and Aisha. Clear, everyone?
Yes, sir.
Sure, that's great. That's great. Next is the question is saying that the value of a constant sine I by sine R for a ray of light passing from air into particular medium is called refractive index of that medium. The air word is used, sine I by sine R. It doesn't mention that N1 or M2, something like that. It just only said if sine I by sine R is constant passing from air into the medium, so that refractive index will be considered as the absolute because air is involved. Right, everyone? Okay, next is the refractive index is a ratio of two similar quantities, so it is a unitless quantity. So when the two similar quantities are basically in the division, so there would be no unit for that. Is this clear to all of you?
Yes.
Sure, that's good. So refractive index can also be written as a ratio of speeds in the two medias, right? So let's understand in terms of mediums. So refractive index of medium with respect to 1 in terms of speed would be speed of light in medium 1 divided by speed of light in medium 2. So if you are writing the refractive index in terms of speed, so reference medium will come in numerator and the actual medium through which the light is going will be in the denominator. Is this clear to all of you? Refractive index of medium 2 with respect to 1 will be equals to speed of light in medium 1 divided by speed of light in medium 2. So this is a relative refractive index. Okay, everyone? Anyone, any doubt so far? Please let me know. Is this clear to all of you? Say yes or no at least, bachcho.
Yes, sir.
Chalo,
Yes, sir.
okay. And if you basically take the opposite of it, refractive index of medium 2 with refractive index of medium 1 with respect to 2, so it would be V2 by V1. And these two ratios are reciprocal of each other, right? This is the relationship. So now let's understand the absolute and the relative in a very short manner. So when the light is going from vacuum to another medium, then the value of refractive index is called absolute refractive index. So for the formula for absolute refractive index is N is equals to C by V. So there you go. In this, we have substituted the velocity by C. V2 is substituted by C because the speed of light is known and divided by V, which is not known. Clear, everyone? N is equals to C by V. Whenever the word comes into the exam, air, and it is asking about the refractive index, you just have to use this formula, that is N equals to C by V. Is this clear to all of you?
Yes.
Okay? Chalo, that's great. Next is relative refractive index when the mediums are like basically when one of the medium is not air, right? Except air, any medium could be used, like water, glass, water, water, sand, not water, sand, basically water, oil, diamond, right? So when the light ray is going from one medium to another medium, other than vacuum or air, then the value of refractive index is called the relative refractive index. So that is V1 by V2. It means that this is refractive index of medium 2 with respect to 1. Because V1 by V2 now, medium 1 velocity divided by medium 2. Right, everyone? Chalo, that's great. So one more thing, yeah. A substance having high refractive index is optically denser. It means that higher the refractive index, higher will be the ability to bend the light towards the normal. Clear, everyone? And lower will be the speed. High refractive index means speed will get decreased. Okay? Because high refractive index means it is more denser. Light will travel at a much slower speed than the rarer medium. Next is higher the refractive index of substance, more it will change the direction of beam of light passing through it. Right, everyone? Okay, that's great. Now, there was a relationship between the, just a second. Acha, when you have to write down the relationship between the refractive index, so suppose that refractive index of medium 2, I'm writing it in a short. Refractive index of medium 2 with respect to 1, it means that refractive index of medium 2 with refractive index of medium 1. This is in terms of refractive index. Or if you want to write it in terms of velocity, so it would be V1 by V2. Is this clear to all of you? Next case is refractive index of medium 1 with respect to 2. So it would be N1 by refractive index of medium 2. And in terms of velocity, it would be reversed, V2 by V1. Is this clear to all of you? Please let me know. This is the conclusion for the refractive index. Is there anyone who is having doubt? Please let me know, yes or no, everyone. Is this clear to all of you?
Yes, sir.
Yes, sir.
Any doubt so far to anyone?
No, sir.
Yes, someone is saying something? Gianna, Aisha, Galvin, Maha, Harshit.
No, sir.
Galvin and Aisha, what happened to you, bacho? Why did you switch off the camera? Oh, that's great. Right now it's raining in Delhi and the weather is so much cool and calm. There is a very cold breeze right now out there. So that's great. So yeah, so this is all about the refractive index. Please let me know, everyone. Is this clear to you or not? We will do the questions of the refractive index when we will solve once we will start the discussion of paper, because like we have almost done every type of questions. So only questions that are remaining is basically the test questions. So we will do the questions based on that. Clear, everyone? Okay. Right now, let's complete the theoretical portion. Okay, until the tests are not discussed. Now let's understand the image formation of spherical lenses. So this is one of the most important, like, or you can say very similar to the lens or mirror part. Right? If you understand the mirror properly, it will be much easier to understand the lens. Convex lens is similar to concave mirror because convex lens and concave mirror are converging in nature. It means that they basically merge the light basically focus a light at a single point. Right, everyone? And concave lens and convex mirror are diverging in nature. They basically spread out the light in the basically in a very basically the inclined manner. Clear? Sure. Now let's understand the basic things about because we have almost more than 20 minutes. So the center of point of spherical lens is called optical center, right? And this is the convex lens. Okay. So convex lens is converging lens. Next is This is the direction of light passing through it. So basically, when the light, so in this convex lens, we have seen that the light is passing through it. So basically, we have two focus and two center of curvature. You can say 2f1 and 2f2. So as the convex lens is basically the light passes through it. So the right side is considered as the primary focus, and this one is considered as the secondary focus. Clear, everyone? Because the light is getting focused at this point, so this is considered as primary focus, right? Okay. And the focal length, as I have told you that convex word is used, so it would be positive. Okay. And convex lens only produces one virtual image. Otherwise, the convex lens produces the real and inverted images. Is this clear to all of you? Same case here, only instead of whole optical center is used. Okay. Focus and optical center. When the object is placed at focus and optical center, the image formed by convex lens is virtual and erect and magnified, similar to the mirror formation, right, everyone? Okay.
Yes.
Next is the primary focus of convex lens is always positive. But suppose that when you will go in the 11th, 12th standard, you will study the ray optics in detail. In that portion, you will find out that the ray, there's a mirror placed here. So the light ray will reflect. So in that case, your mirror focal length will be negative. So right now it's not that much deep, but you will understand these things like multiple mirrors and the lenses are placed right there in the combinations. So it's very easy, like only simple part. Like the thing that you have studied right now will be there in the 12th class as well, but with the more detailed portion. All the things that we are doing, exactly same copy pasted is present in 12th standard. But except in the lenses part, microscope is there, telescope is there, and you can say lens formula is there, lens, how to basically form a lens and all the things. So the ray optic is is present in a very detailed manner. So you will find it very interesting. You will find that thing very interesting. Okay. So next, understand the formation of the convex lens, image formation. So when the light rays are parallel to the principal axis, the light ray will focus at infinity. When the light rays are parallel to the principal axis, so the light rays will focus at f1, the primary focus, right? So object is at infinity. Image is formed at the f1. So image would be formed real and inverted and highly diminished. Clear? Okay. So this is the basic case. Next is when the object is placed at 2f2. Now the object will move towards the optical center. So now the next position is the 2f beyond 2f2. Okay, so object is placed right there. So our first ray will be parallel to the principal axis, right? Without any doubt, you just have to draw a parallel ray and it will pass through the focus. In every case of the mirror and lens, any type of mirror, any type of lens, we have done the same thing, right, everyone? Okay.
Yes.
And it will pass through the focus. Another ray that we are basically using is passing through the optical center, because when the light ray passes through the optical center, it will not refract at all, right? So it will not refract at all. So that's why the image formed is between f1 and 2f1, and it is inverted in nature. As you can see this thing, that the object is basically larger than the image form. So in this case, image would be diminished, real and inverted. So image formed between f1 and 2f1, and the object is placed beyond 2f2. Is this clear to all of you? Sure, that's great. Now the most simplest part, like the infinity part and the center 2f2 part, is very simple. Okay, when the object is placed at 2f2, the image formed would be of the same size and of the inverted in nature, right? So, and the one more thing is that image will also formed at the 2f2, 2f1 basically on the right hand side. So image is forming, first ray will be parallel to the principal axis, pass through the focus. Another ray that is passing will be through the optical center. Please avoid the asymmetry right there. Okay. So it will passing. So as you can see, the image is formed at the 2f1 and of the same size. Clear, everyone? Okay. So that's what it is. Same size, real and inverted. Object distance and both image distance are same, just in the opposite sides. Next one is when the object is placed between 2f2 and f2. Now the object will move towards again to the optical center. Now the object is placed between this here. So the first ray will be parallel to the principal axis and it will pass through the focus. And another ray would be parallel, basically passing through the optical center without any refraction. So this point is basically intersection point as you basically take the measure from the principal axis. So the image formed would be inverted in nature and of the enlarged size. Right? Yes or no, everyone?
Yes, sir.
Sure,
Yes,
that's
sir.
great. That's great. Just next, second last case, when the object is at focus, the rays will be parallel to the refracted rays will be parallel to each other, and they will meet at infinity, because in the maths we have studied this thing. When the light rays are parallel, basically they will intersect at the infinity. So that's why the image formed is at infinity and it is highly enlarged. Clear, all of you?
Yes.
Sure, that's great. Last case, when the object is placed between focal length focus and the optical center. So object is placed right there. So the first ray will be parallel to the principal axis. Another ray would pass through the optical center. So as you can see, they are basically diverging from each other. So if I extend in the backward direction to find out whether they are originating from a common point or not. So if I extend it in the backward direction, there is a point at from which you can say the rays are getting originated. So this is our like just the assumption. So that point is considered as the image formation. So the image formed is in front of the lens in basically virtual and erect and the enlarged, right? Yes or no, everyone?
Yes.
Sure, that's great. Okay, now this is the summary of this table. So like if you want to understand, if you want to memorize, basically no memorization would be required if you understand it basically with the concept. You will just say this thing, okay, this is the thing, okay, the image formed would be beyond 2f2, between f1 to f2, something like that. Okay, so now let's understand the use cases of the convex lenses. The first case is used to correct the defect of vision, that is hypermetropia, right? We've studied in the human eye chapter. Next is the convex lens is used as the magnifying glass to see the very small text or small objects. So that's why we use the convex lens as the magnifying glass. And which, can you tell me which case is used in the magnifying glass among all these 6 options? Can anybody tell me which case is used in the magnifying glass? Anyone?
Convex lens.
The
Yes, Maha, you're saying something, Maha? I'm asking which case is used in the convex lens when it is used as a magnifying glass among the 6 ray diagrams. This is a one marker MCQ. If anyone wants to create a question from it, it is a very simple and straightforward concept. The last
Sir,
option, Bacho, when the object is placed between
yes.
focus and optical center, that's how the image, the virtual, is it possible to read the inverted text?
no.
So only case left is when the image formed would be erect. That is how it is possible. So the last case is only applicable, that is forming the virtual and erect images. Right, everyone? Harshit, Galvin, Maha, Gianna, Aisha.
Sir, could you explain the meaning of erect too?
Erect means upright. It means that if I'm sitting right with the upper body in the upwards direction, my image would be in the upright direction. Right?
Okay, sir.
Yeah. Any doubt, Maha, Galvin, Gianna, Harshit, and Aisha?
No, sir.
Yes, sir.
Okay. So this is a one marker question. So when you go through the notes, when you study these things in this manner, you will find out multiple types of MCQs that could be formed by your own itself, and you could answer them easily. And that's how the progress is, you can say, measured. Right, everyone? So try to study with this kind of mindset, like try to create your own question. Like if this is the thing, so this could be a question. If this is the thing, this could be a question. So when you do this kind of thing, now you can easily solve any kind of question when it comes when basically when you will sit in the exams, right? Try to develop this kind of mindset. When you study this thing, I've created this question on the spot. I just like I said now, which case is used in the magnifying glass when it is okay. So that's why when you will solve this time, when you will basically want to create this kind of question, you could easily understand this concept in a very clear manner. Okay. Last is convex lens is used for for making a simple camera. So simple camera, it means that the lens used in the mirror, basically in the camera, is made up of convex lens. Our eye also have the convex lens, right? Now let's understand. We have only 5 minutes, so concave mirror is not that much bigger, right? So now image formation by concave lens. So concave lens always produce virtual and erect and diminished images, right? And it has a negative focal length. As I've told you, concave means negative focal length, both mirror and lenses. Now, first case is that when the object is placed at infinity, the parallel rays would be there. It will be parallel to the principal axis and it will pass. Okay. So the property of this concave lens is that it will diverge, right? But if I extend them, so if I extend these rays in the backward direction, I will find out that they are basically intersecting at a common point, that is the focus. So that's why from the optical center, I'm going in the left side. So that's why the focal length of this lens is negative. Am I clear to all of you?
Yes.
Maha, Harshit, Galvin, Gianna, Aisha. Am I clear? Next is, so the image would be highly diminished, virtual and erect. Okay? Because these are the imaginary rays, not the actual intersection. Last case, okay, between infinity on optical center, similar to the convex lens, or convex mirror, sorry, and the object is placed between infinity and the optical center, the image formed would be diminished and between the primary focus and the optical center. So first ray would be parallel, it will diverge, but if I extend in the backward direction, it is intersecting at focal length or focus. First, the second ray will go without any refraction. So this intersection point will give you the image, and that is in the diminished size. Am I clear to all of you? Please let me know, everyone. Is there anyone who is having doubt? Maha, Harshit, Galvin, Gianna, and Aisha.
No, sir.
No, sir.
Okay. Now let's understand the use case of the concave lens. Concave lens is used to correct the defect of vision, that is called myopia. So most of the students and you can say most of the children are basically are having myopia, right? So myopia means the distant vision is not clear, right, everyone? And concave lens is used in Galilean telescope. So it's a type of telescope used to see the terrestrial objects into this outer space. So that's why concave lens is used. Am I clear to all of you? Please let me know, everyone.
Yes, sir.
Is there anyone who is having doubt?
No, sir.
Okay, that's great. Just allow me a moment, everyone. This is our fourth class of revision or the third class of revision?
Third
It
class, I
seems,
think.
yes, it seems third, I think so. So we are doing the revision, you are going through the test series as well. So now do the revision as much as you can, do practice the numerical as much as you can. We have done a lot of numerical in the class itself. And we have like you have the question paper of the test itself, you have the NCRT, And I've also shared a book that is the Lakshmi Singh and Manjeet Kaur book. I think everybody has this book.